Hey everyone, and welcome to The Explainer. I'm absolutely thrilled to have you here today. Look, if you're the kind of person who loves tearing things apart to figure out how they work from the ground up, you're in exactly the right place. Today, we're going to explore a piece of tech that has literally sparked millions of electronics projects all over the globe, the Arduino Uno. Let's look under the hood of this incredibly popular, super approachable platform and see exactly what makes it tick. Okay, let's dive right into this. Before we even touch the physical board, we really need to understand the core concept driving it, and that's the microcontroller. Think of it as a tiny, highly dedicated computer. It acts as the central brain of your device. But unlike your laptop, which is constantly juggling thousands of background processes at once, a microcontroller is totally focused. It's strictly responsible for executing a dedicated set of tasks exactly according to the program you write for it. It just sits there, waits for your instructions, and then flawlessly executes them. Now, this little brain doesn't just throw in one flavor. There's actually an entire diverse Arduino family. You've got the Nano for those really tiny space-constrained projects, the Mega for when you need just a massive amount of inputs and outputs, plus the Leonardo, the Do, the Pro Mini, and the Micro. They come in all sorts of shapes and sizes depending on what your project needs in terms of speed or pin count. But today, we're zooming in on the undisputed king of the hobbyist world, the beloved Arduino Uno R3. Here is our roadmap for today. We're going to meet the Arduino Uno, break down the anatomy of its brain, figure out how it connects to the world, talk power and safety, write your first program, and finally, simulate the whole shebang in Tinkercad. Section 1. Meet the Arduino Uno, the beginner-friendly, open-source platform. So the Uno's true superpower is that it's an entirely open-source platform. And what does that actually mean for you? Well, it means the hardware is incredibly straightforward, and the software tools you need to make it run are completely free and widely accessible. You absolutely do not need an electrical engineering degree to get started here. It's basically the ultimate frictionless bridge between physical, electronic components and digital code. It's designed from the ground up to empower absolute beginners. Section 2. Anatomy of the brain. Let's dissect the ATmega 328P and its heartbeat. All right, time to put on our lab coats and look at the vital organs. Right at the center of it all is the ATmega 328P. This is an 8-bit microcontroller, and it's the central brain. It's the actual physical chip that stores and executes your code, bossing around all the other components. Then we've got the ISC-P, or in-circuit serial programming pins. Think of this as the direct programming nerve center. It handles advanced communication, like burning a bootloader directly to the brain. And lastly, the crystal oscillator. And the magic number here? 16. That crystal oscillator we just mentioned acts as the rhythmic heartbeat of the board, and it beats at an insanely fast 16 megahertz. By converting DC to AC power, it pushes out this repetitive waveform, a steady clock signal. And this precise 16 megahertz frequency dictates exactly how fast our little ATmega brain can execute the instructions you're feeding it. It is lightning fast. Section 3. Connecting to the world. Let's look at how the board senses and communicates. Okay, so we understand the brain, right? Now we need to understand its nervous system. A crucial concept here is the difference between two types of communication. Out-of-circuit communication is when your laptop talks to the Arduino via a USB cable to send your code over. Those are two totally separate devices talking. But once the board actually has that code, it needs to talk to its own internal components. That's in-circuit communication. To bridge that gap, the board uses a specialized USB-to-TTL chip, usually the CH340G. This brilliant little chip translates the USB signals from your computer into serial data, stuff like UART or I2C protocols, so the internal network can actually understand what's going on. So how does it physically connect to the outside world? Through its pins. Along one edge, you've got 14 digital pins, numbered 0 to 13. These are mostly used to send out digital signals, simple on or off commands, to actuators like displays, motors, or LEDs. On the flip side, you have 6 analog pins, labeled A0 to A5. These are absolutely crucial for the board to sense the environment. They hook up to sensors that measure variable stuff, like light intensity or temperature, and use an analog to digital converter to translate those messy real-world signals into clean data the brain can process. Right alongside those standard pins, you'll spot some highly specialized support pins. Pin 1 is TX, meant specifically to transmit serial data, and pin 0 is RX, meant to receive it. There's also an ARF pin for setting a custom reference voltage for your analog inputs. And of course, the GND or ground pins. These provide the 0-volt reference point that is absolutely critical to completing literally any electrical circuit you build. You're going to use ground in almost every single project. Section 4. Power and safety.
how we protect the brain.
So we've got this amazing but delicate electronic brain and nervous system. How do we power it up without completely frying it? Honestly, one of the most unsung heroes on this entire board is the voltage regulator. The concept is super similar to a Zener diode, keeping the output perfectly steady even if the input is jumping all over the place. Think of the voltage regulator as a tough club bodyguard. If you accidentally hit the board with way too much power, say 10 volts directly to the sensitive bits, the board would instantly fail. But the regulator steps in, intercepts that wild power, and calms it down into a smooth, safe flow. And what does that smooth, safe flow look like? Exactly 5 volts. Whether you're powering the Uno through the USB port on your laptop, or you've plugged a 7 to 12 volt battery pack into the external power jack, the voltage regulator catches it, processes it, and guarantees that exactly 5 steady volts make it to the microcontroller. It's basically your ultimate safety net. Section 5. Writing your first program and bringing Pen 13 to life. All right, hardware mastered. Let's seamlessly pivot over to the software side and bring this thing to life using a little built-in LED that just happens to be hardwired to digital pin 13. To make the magic happen, you need your software arsenal. First up, grab the free Arduino IDE, that's Integrated Development Environment. The code you'll be writing, it's C++. You'll use a standard USB Type-B cable to dump that code from your computer straight onto the board. And hey, right there on the board is a physical reset button. If you ever want your program to stop what it's doing and restart from the very top, just give that button a tap. And this brilliantly illustrates just how accessible C++ coding can actually be. Let's walk through this super simple 4-step logic to make that LED blink. Step 1, declare to the brain that digital pin 13 is your target. Step 2, give it a digital write high command. That turns the pin on, and then you tell it to wait for 1,000 milliseconds, so 1 full second. Step 3, digital write low, which turns the pin off. And step 4, because this code lives inside a loop, it jumps right back to the beginning. High, low, high, low. Boom! You just built a blinking light. Section 6. Simulating in Tinkercad, your risk-free digital playground. Now, what if you're sitting there thinking, I want to try this right now, but I don't even own an Uno yet? Well, you're in luck because you can do it without spending a single dime. Tinkercad is this completely free, browser-based website, and let me tell you, it's an absolute game changer. You literally just drag and drop a virtual Uno onto your screen, wire up virtual LEDs and sensors, open the code editor right there in the browser, type in that C++ loop we just looked at, and hit Start Simulation. Your virtual LED will start blinking right in front of you. It's a completely risk-free playground to test out the entire pipeline, from hardware to code. So, we've journeyed all the way from defining that tiny 18-mega brain to exploring its analog and digital nervous system. We've seen how a voltage bodyguard keeps it safe, and we even walked through our very first C++ program. The power to create is entirely in your hands now, and the tools to do it are completely free. So I'm going to leave you with this. Now that you know the true anatomy of the Arduino Uno, what are you going to build first? Thank you so much for hanging out with me on The Explainer today. And hey, happy building!